To be able to put a bog back together hydrologically, I think it's key to understand how they took it apart. And this huge raised bog was first cut into in medieval times, nibbling around the edge. But the major first inroad into the drainage of the mosses came with the enclosure awards of the late 1700s and the early 1800s, when the big landowners put pipes through the hills that were containing the moss, and they cut in the peat arterial drains. And these drains were specially designed, you can see them at number 1 on the map, they were specially designed to canalise the lag stream, which originally would have run all the way around the edge of the Great Raised Dome, taking mineral-rich water from the surrounding mineral ground and acidic water from the raised bog. And by canalising these drains into the peat, it means they could lower the water table and really set to exploit the moss. Now, fortunately, in 1807, they actually built a canal through 2 miles of Whixall moss. You can see it, number 2's on the screen. And where they came across an arterial drain, they put a culvert under the canal. Now, the inverts of these culverts set the minimum water level that anyone could drain their bog upstream down to for the next 200 years. So they've saved the moss. And the second thing that saved the moss, ironically, was hand peat cutting. If you look at number 3 on the map, the Lord of the Manor for England let Whixall moss out to the local men to cut domestically for their own peat, to carry on cutting for their own peat. Now, because of that, they were cutting by hand. When they abandoned an area, the little drains would all block up and the water level would sit in the bottom of the peat cuttings, and the bog species could survive there while Fenn's moss was being commercially devastated. Moving on in time, number 4, they slapped a railway across the bog, which of course was useful for commercial exploitation of the peat. But 5 is interesting. Look at the 2 5s. In the First World War, they put 9 rifle ranges on the moss. They put the drainage in for them. You can see some of the diagonal lines. And the rifle ranges in the foreground were shooting towards the rifle ranges at the background of the picture, the top number 5. The ones in the background were shooting towards the ones in the foreground. And that tells us something interesting about the moss at that time. They didn't kill each other. And that means that the dome was still present during the First World War on Fenn's moss. It was still a raised bog dome. Otherwise, they'd have killed each other. Now, all that changed if you look at number 6, when just after the war, they brought the Dutch in to systematically drain down Fenn's moss. See all the oblongs? They put drains in down the sides of the oblongs and down the centre of the oblongs. And then every 10 metres, they started peat cutting, the little tiny white stripes. And all of these drains are interlinked into the big arterial drains. And of course, Fenn's moss collapsed down, no dome anymore. By the Second World War, the firm had disappeared. The commercial firm had disappeared because coal had replaced peat. So instead, as a bonus, the northeast Fens, where number 7 is, we got a bombing range. The whole of the northeast Fens was taken over for a bombing range. In the 1950s, compost reared its ugly head for gardening, and a local firm took over the moss. They bought the freehold of Whixall Moss and Bettisfield Moss and the leasehold of Fenn's Moss for next to nothing, because peat was worthless and they started cutting on the Dutch system. See where the number 8 is? You can see some of the old cuttings there. Same system. And they exported the compost peat along the railway line, the mainline railway. The bog was worthless, so why not plant a whole load of conifer forests around the north end of it, which you can see number 9 there. In the late 80s, the Hanmers, the lord of the manor that owned the Welsh side of the bog, Fenn's Moss, got a lot of death duties. So they raised the commercial rental by a factor of 4, and the local firm backed off, and a great big firm came in from Manchester and started tearing the bog apart to meet the high rental. There was a national outcry to save the site, and the government, meanwhile, had realised how rare peat bogs, raised bogs were. They didn't have enough to meet their international obligations that were in good conditions. So they took on this amazing challenge of mending this devastated bog. And in 1991, we started. Boosted, of course, in 2016 by the BogLIFE programme. It was almost total destruction. One drain every 10 metres, Bettisfield Moss covered in pine trees, English side of the moss, mainly fields, and we even had our own scrapyard. We started with the green bits, and every year we've been buying more and more and more little bits of the moss, doing the jigsaw, 50 more acquisitions. And the nearer we got to the edge, the worse the land we were buying came in. You can see at the top of the photos, pine forests. A lot of it was fields. Quite a lot of it had been drained and abandoned and gone over to woodland or to secondary pine forest. So we cracked on doing the first fix. First of all, cut down the scrub, cut down the scattered trees to stop any further invasion. And if we could dam it, keep on top of what the scrub that was regenerating on the moss until the bog vegetation had established. And if we couldn't dam it, just keep on top of it until we could. And our men went in with their excavators and dammed up, well, we have one excavator. They went in and dammed up every ditch we could possibly dam up. You can see that it was partially successful. The damming was peat. You can see a peat dam centre bottom, and you can see the wonderful green sphagnum coming back on the right-hand side. Because the moss levels were all over the place, we had to install a lot of stormwater pipes. Otherwise, the moss would just rip itself to pieces. But we were aiming for that water within 10 centimetres of the surface. We managed to land some foot and mouth money that no one else could spend to tackle some of the bigger projects. You can see top left, clearing the pine forest off the 6 metres of black jelly that was Bettisfield moss, using a skyline to drag the trees to the edge. Top right, clearing northeast Fenn's shallower peat, again manhandling all of the trees to the edge of the bog and taking them away. We have enormous problems with scrub regeneration, so we have to limit any nutrient input to the moss. By 2010, we'd acquired enough fields near the edge of the Whixall side to actually tackle a major engineering scheme. The Whixall Manor drain was bringing washing powder and septic tank effluent up onto the peat bog. So we decided that we would divert it back where it should be, nearer the edge of the moss, because it was bringing all that pollution right across the centre of the sack site. This enabled us to put a watershed dam in on the main drain between England and Wales. That kept all of the dirty water on the English side, and it meant that we could put a big weir in at the downstream end of the Fenn's Moss main drain. That let us hold the water in that big arterial drain up to support the dammed peat cuttings on the sides, on the peat cutting flats. And then we eventually, after 25 years of scrimping and saving, managed to land €5 million for our BogLIFE project, which has turned into a 6-year project. And this is letting us do a second fix on the hydrology of the moss. The relevant hydrological actions are firstly to construct a hydrological management plan, and then to secure permission to do the work. And then the important bit is the bits you can see on your screen surrounded in yellow lines, and that was to acquire even more land on the Welsh side, forests, on the English side, excitingly, fields. It should be lag, so we can try and reconstruct some lag vegetation on the edge of the moss. With the forests, section C2 is the stripy dark green stuff, fell the forests, and then light green stripy, fell the woodlands. And then the important bit is this pale blue area, right the way round the outside of the mid-blue area. The mid-blue area is what we've already dammed. The pale blue area is land without any obvious drains to dam. Or, like the big centre-left block, land on a slope where no matter how many times we dammed it, the water just ran through the damaged surface peats down the slope. And this pale blue area was to be using the newly discovered, from Cumbria, the newly discovered linear bunding technique of repacking the surface peats, which I'll talk about a bit later on. The mid-blue area is action C4. When we were restoring the moss, damming it, we dammed each oblong, each peat cutting flat individually because of the mess of levels the peat cutters left. And the BogLIFE project is to marry all of those together. So we lose some of the trackways, but we'll have bigger hydrological units there. We also have problems with pollution. And if you thought that that scrapyard in the bottom right-hand corner is filthy enough, even though we've taken the tyres and the scrap off it and we've covered the asbestos in it, then from the bog's point of view, just think about the nitrogen pollution falling out of the air onto it and every other SSSI more or less in England. Action D is to monitor the effects of what we were doing. Other hydrological drivers are the peat integrity and the topography that you're left with. We were left with 5 different peat cutting types, tiny residual areas of uncut peat, the yellow bits. Some so badly damaged, like the picture in the bottom corner, Bettisfield moss, completely covered in self-sown pines. The blue bits and the green bits, not too bad. They're the old commercial cuttings where the bogs persisted in the bottom of the cuttings, but the bulk of the surface was dry heath or forest. And the red bit is an interesting bit in the middle. When I came, it was a desert, the top left picture. Just row upon row of stacked peat, ditches, drains deeper than your head, not a drop of water in sight on this important raised bog. Now fix your eyes on the red bit, because this is Richard Lindsay's impenetrable isometric view of the peat surface of that red bit, the commercial cutting that he did when we were trying to acquire the bog. Dense colour means low areas. You can see our raised bog dome has a big saucer cut in the middle of it. We haven't got a raised bog topography anymore, and this is critical. Every single oblong is at a different level, and so you've got to be very careful when you're blocking it up. Richard also gathered loads of peat depths, a lot of the depths in the middle. We've been adding to them since as we've acquired land, because peat depth is another hydrological driver. But water quantity principally depends on climate. We're in the Welsh rain shadow. You can see how little rain we get, 750 mil for most of the time. When I started, the average was 625 mil for 10-year average. It's gone up a bit with climate change, but look at the 30-year variation. When I started in 1991, we got 495 mil. 2 years ago, we got twice that. We either get not enough or too much. We go from drought to flood. And it's important, the peat depth interacting with that, especially in these summer droughts we get, because the shallower peat leaks into the sand. Obviously, the deeper peats are in the southwest, where the bog began to form, 6 metres on Wem Moss, Cadney Moss, Bettisfield Moss, 4 to 5 metres in the centre of Fenns and Whixall Moss, and then 3 metres on average in the rest of Fenn's Moss, growing to the yellow line, which is the boundary, the 30 centimetres of peat. We're lucky. This isn't the Fens where the peat goes on forever and ever and you're trying to manage water in the middle of everybody else's water. We've got quite a well-defined blob of peat left. Obviously, another hydrological driver is the vegetation. We know our pine trees intercept 30% of the water before it even gets to the ground, and then evaporation from those, the birch and the heather, takes another chunk out of our rainfall. So the minute we get a forest, we fell it. We've got to be very careful though, because we have to mend the bog after the timber fellers have been in. So if we can skyline or control where the brash tracks are put, it means that we can get to the ditches and control any regrowth and wet the bog up afterwards. Another driver for us is the permeable peat surface. The damage caused by the drainage means that for at least 50 centimetres, water can just run through the surface peat. So no matter how you dam it up, if it's at all on a slope, the water's going to run out of it. So we were very lucky that they'd invented this new technique of damming where you dig up the top metre of peat and smash it back into the ground and leave little buns above the ground of claggy, smashed up peat, which you then cover, as you can see in the picture, with surface vegetation to stop them cracking. And you can see the royal blue on the picture, which was the original bunding plan. You can see some of the cells in it. You can see the maroon colours, which are additional areas that Dinsdale Moorland Services have bunded or dammed for us. So we're encircling the white bit in the middle, which is our first fix of dams. Another hydrological driver is water quality. Now, over the years, we've tackled some of the pollution, the washing powder from the moss cottages, pig slurry from Wem Moss, the wildlife just stopped that, and we chopped down the forests. But in the restored bog, we've got to be very careful because big pools attract birds, and then we get far too high pH in the water for sphagnum to grow, to mend the bog. We also have upwellings with mineral water coming out of the sand underneath the bog, and I've already mentioned the astronomically high critical nitrogen load coming from agriculture around the bog, which is encouraging Molinia and birch. And also the mineral water coming in from the lag streams. So one of our latest ventures has been to put the Bronnington Manor drain back to the edge of the bog. If we could, to avoid digging a big sandy channel that'll drain the edge, we've put it culverted through pipes across the peat bog, like you can see in the bottom right picture. Otherwise, we've had to dig a new channel, which will allow us to dam the old channel. And this lets us bund, as you can see in the bottom left, the peat that is to the north side of that drain. And already the winter storms have done us proud, filling it up. Now on to salmon and monitoring. My kind of monitoring is, first you see a peat cutting, a forest cleared desert. So you've got nothing, you've got desert, and then you cell-bund it and you take a picture and Bob's your uncle paddy fields. But when we started, I knew about climate change. I knew that raising water levels when a community has spent 500 years draining a peat bog was going to be controversial. So we put in a lot of hydrological monitoring, putting 3/8 inch gas pipes down right to the bottom of the peat so they don't ride up and down in the peat. And once a month, the volunteers go out to these 130 odd dip wells and measure how deep below the peat surface the water is. We also have some constant water level recorders, more so with the LIFE money we've got. We put in lysimeters and evaporation pans. Olivia Bragg helped us with that. And because we knew we were going to fettle on with the main drains, we put in some crest gauges which measure the variation in water level up and down in the main drain. And here is the dipwell cross on Fenn's and Whixall moss, and on Bettisfield moss, the dipwell transects that cover all sorts of different bits of the cuttings and the intact ground.